Hello everyone. Welcome back to another exciting chemistry lessons from Adrenaline, the Bazooka Prophet. So without wasting much time, this is another series under electrochemical cells, talking about the calculations that are involved. But before we talk about the calculations that are involved, I'm going to be diving deep into the formulas that are necessary to solve questions. Now, this particular aspect of chemistry is for students preparing for NEET exam, JTE exams, Cambridge A-level exams, and all A-level exams. Now, let us go quickly. Now, we'll talk about conductance. What is conductance? Conductance is simply the reciprocal of resistivity. Please take note. Or conductance can be defined as the ease in which what now? In which current flows through a conductor. Take note. Now, the symbol for conductance is G. Please take note. The symbol for conductance is capital letter what now? G. So conductance G is simply what now? The reciprocal of resistance. Is that clear, Nana? And it is the measure of the ease with which what now current flows through a conductor. And that is how we should take note of them, so that we can simply say that conductance G is simply equal to 1 over resistance. And what is resistance? Resistance simply means the obstruction to the flow of current. While conductance is the reciprocal. Is that clear? And please do take note. Let me erase this part here. Now do take note that basically the unit of resistance is ohms, right? So the reciprocal of this resistance will be an inverted sign like this. Is that clear? But the SI unit of conductance is Siemens. Take note. This is the SI unit of what now? Conductance. Now we'll move straightway, please, to what we call specific conductance. Now please take note. The other name of specific conductance can also be called conductivity. Conductivity. And the symbol for conductivity is kappa, from the Greek word kappa. K. See it now? You see it now? This is, let me do it for you. This is what kappa. So that conductivity is simply the reciprocal of what now? Resistivity. Is that clear? And you are aware that normally, or basically, you are aware that resistance that resistivity is simply RA over what now? The length. Now, whereby resistivity is equal to R here means resistance, A here means area, while L here means what now? Length. In what length? Is that clear? So that the reciprocal of this now will just simply mean 1 over resistivity, which is also called kappa, right, is equal to, remember, we invert it, length over resistance multiplied by what now? Area. And this is it. Please do not take note of these formulas, because in our subsequent video, we are going to be using all these formulas to calculate questions from A levels. Now move straight down to two major important parts whereby the calculations will be dealt with here is equivalent conductivity, and molar conductivity. They both have the same formula, but their definitions are not the same. The definition for equivalent conductivity is simply the product of conductivity of the solution and volume in centimeter cube, that's not cc, centimeter cube containing 1 gram. Look at it. The difference between these two is that this one is containing 1 gram equivalent of electrolyte, and therefore the unit is what now? Siemens meter square per equivalent. While this one is Siemens meter square per mole. Take note, they both have the same formula. And first of all, you are aware that the equivalent conductivity, which is like this, is equal to the product of what now? Conductivity multiplied by the volume, which is also equal to what now? Kappa, which is conductivity multiplied by 1000 over this M here means molar concentration. Molar concentration. So this is for equivalent conductivity, but for molar conductivity is simply equal to the same formula, K multiplied by 1000 over molar concentration. Now, there is one I would love to tell you now, which is sec constant. Sec constant. Now, please take note of these two formulas. This one is 1 gram, this one is 1 gram per mole. These formulas are what you are interested in. But there's a last aspect here I should tell you. And this last aspect here is talking about what we call sec constant. That sec constant is simply equal to conductivity K over G, which is conductance, meaning conductivity multiplied by conductance. Please take note of this formula because we are going to be doing them right about now. For now, stay blessed. Love you guys. Love you.